Welcome to MRL. In this learning session, we'll be learning about rational numbers. Now, what is a rational number? A number of the form p by q, where p and q are integers and q is not equal to 0, is a rational number. Please remember, a number of the form p by q is a rational number. A rational number also can be defined as a ratio of two integers. P is an integer, q is an integer. So take a ratio of p and q, then it is a rational number. Only condition is that q should not be equal to 0. The word rational is derived from the word ratio. The symbol of rational number is q, which is again derived from the word quotient, because p by q gives us a quotient. Now q is equal to, within the braces, x is such that x is of the form p by q, where p and q are integers and q is not equal to 0, is a set of rational numbers. Now if you take natural numbers, 5 is a natural number. 5 can be written as 5 by 1, and therefore 5 being a natural number, it is also a rational number. That means all natural numbers are what we call all natural numbers are rational numbers. So please remember. So also the whole numbers are rational numbers. 0 is a whole number, but 0 can be written as 0 by 1, and therefore every whole number is a rational number. Similarly, integers are rational numbers, because minus 5 is an integer. Minus 5 can be written as minus 5 by 1, because minus 5 by 1 is again minus 5, which is an integer but also a rational number. Therefore every integer is a rational number. Similarly, every fraction is a rational number, and every decimal is also a rational number, because the decimal number 0.2 or any decimal number can be written in the form p by q, which is a rational number. Therefore every decimal number is also a rational number. The conclusion is every natural number, whole number, integers, fractions, decimals are all rational numbers. So if you see here, we can represent the rational number set as a rectangle. That is the Venn diagram here. The rectangle represents the set of rational numbers, and within that we have n, that is natural number set, whole number set, and integer set. This is the geometrical representation of the what we call a set of rational numbers, which is referred to as Venn diagram. Please remember that. Now, positive rational numbers. A rational number in which both the p and q are having the same sign are called as positive rational number. Therefore we say p by q is a positive rational number if p and q have like signs or signs are same. Negative rational numbers. If p or q, either of them, p or q, if they have a negative sign, then they are negative rational numbers. P by q is a negative rational number if p and q have unlike signs. Now, writing rational number in a standard form. If you are given a rational number 60 by minus 40, the first thing is, you see there is a negative sign in the denominator which has to be removed. Rather, the denominator has to be made positive, and that can be done by multiplying by minus 1 in both the numerator and the denominator, so that the numerator becomes minus 60, the denominator minus into minus plus, that it becomes positive, or the denominator has been converted to positive sign. Then minus 60 and 40, they are not co-primes, so we can divide 60 and 40 by their HCF. The HCF of 60 and 40 is 20, so if we divide 60 by 20 and 40 by 20, we get minus 3 by 2. And if you observe here, minus 3 by 2 is in standard form, or it is the simplest form of 60 by minus 40. 3 and 2 are co-primes, that means they have a common factor as 1. Therefore, the procedure is, a rational number p by q is in standard form if q is greater than 0 and p and q are co-primes, or common factor of p and q is 1. Now, standard form also is the simplest form of the given rational number. Therefore, minus 3 by 2 is the simplest form of 60 by minus 40, or minus 3 by 2 is such that where 3 and 2 are co-primes, 3 and 2 have common factor as 1, and there is no negative sign in the denominator, and this is the standard form, or also the simplest form of the given rational number. You have to follow this procedure to write a given rational number in standard form or in the simplest form. Now, what are equivalent rational numbers? Now, equivalent rational numbers means the rational numbers which have same simplest forms. Okay, please remember, that means any given rational number or given rational numbers if they have the same simplest form, then they are equivalent rational numbers. Or the rational numbers which have equal cross products are also called as equivalent rational numbers. Let us take an example and understand this. Minus 4 by 3 and minus 16 by 12 are two rational numbers. Now the simplest form of minus 4 by 3 is minus 4 by 3 only, whereas simplest form of minus 16 by 12 will be obtained by dividing the numerator, that is p and q, by their HCF, that is 4, we get minus 4 by 3. And if we observe, minus 4 by 3 is minus 4 by 3, minus 16 by 12 is also minus 4 by 3, therefore minus 4 by 3 and minus 16 by 12 are equivalent rational numbers. So please remember that. Now also, if you take the cross product, minus 4 into 12 is minus 4 into 12 is minus 48, 3 into minus 16 is minus 48, LHS is equal to RHS, cross products are equal, therefore these two rational numbers are equivalent rational numbers. So therefore, to find whether the given rational numbers are equivalent or not, find their simplest forms. If the simplest forms are equal, then they are equivalent, or find their cross products, and if the cross products are equal, then also the rational numbers are equivalent. Now, what is the methods of finding equivalent rational numbers? Now, if you are given a rational number p by q, if you are asked to find out as many equivalent rational numbers, then the method is very simple. Multiply p and q with some non-zero integer, or divide p and q with some non-zero integer to get equivalent rational numbers. Let us consider an example. Minus 4 by 3 is a rational number. We want to find equivalent rational numbers for minus 4 by 3. For that, minus 4 by 3 is, if I multiply by 2 and 2 in the numerator, that is by 2 p and q, then I get minus 8 by 6. So minus 8 by 6 is an equivalent rational number of minus 4 by 3. Multiply 3 by 3 and 3, we get minus 12 by 9. Again, minus 12 by 9 is equivalent rational number of minus 4 by 3. Rather, for minus 4 by 3, minus 8 by 6, minus 12 by 9 are equivalent rational number. Rather, all these three are equivalent rational numbers. So please remember that. Now, equality of rational numbers, very simple again. If p by q is a rational number and r by s is another rational number, they are equal if they have the same simplest form, or if their cross products are equal. That means p by q and r by s, when simplified, should have the same standard form or the same simplest forms, or their cross products must be equal. That means ps must be equal to qr. Let us consider an example. Now, if minus 44 by 77 and minus 8 by 14 are two rational numbers, the simplest form of minus 44 by 77 is minus 4 by 7, and minus 8 by 14 simplest form is also minus 4 by 7, and therefore these two are equal rational numbers. That is what you have to remember. And also, if I take p by q and r by s, if I take cross product, that is ps and qr, if they are equal, still they are equivalent rational numbers or equal rational numbers. For example, minus 44 by 77 and minus 8 by 14, if I take a cross product, minus 44 into 14 is minus 616, 77 into minus 8 is again minus 616, and therefore the cross products are equal. Therefore, these two rational numbers are equal rational numbers, and please don't forget that. Expressing p by q of required denominator. Now, what is this? Now we have a rational number minus 5 by 8. The 8 is in the denominator, but we want to express this rational number with the denominator of 64. And to do that, very simple, multiply 8 by 8, it becomes 64. But we cannot multiply 8 only in the denominator, we have to multiply in the numerator also. So by multiplying by 8 in the numerator and the denominator, we get minus 5, 8, 40, and 8 into 8 is 64. So minus 40 by 64 is the rational number of which is having a denominator 64. So that is how we can express any given rational number of any required denominator. Now, rational numbers on a number line. A horizontal line which represents rational numbers is a rational numbers number line. That means we draw a horizontal line, take a point representing 0. To the right we have what we call them as positive rational numbers, and to the left we have negative rational numbers. Now, if you observe here, I have taken 0 to 1. I have taken 0 to 1 here, and I have divided into the 0 to 1 into 4 parts. 1, 2, 3, 4 parts. The first part is 1 by 4, second part is half, third part is 3 by 4, and the fourth part is 4 by 4, that is 1. That means we can represent the positive rational numbers, the negative rational numbers on a number line, and therefore a horizontal line which represents rational numbers is known as rational numbers number line. So please remember, on the right side of 0 are positive rational numbers, and on the left side of 0 are negative rational numbers. Every negative rational number is less than 0. Every positive rational number is greater than 0. Every rational number on the right side of a point is greater than the one which is on the left side, and every rational number on the left side is definitely smaller than the rational number which is on the right side. Now, representation of rational numbers on a number line. We are discussing about how to represent the two rational numbers 3 by 5 and minus 3 by 5 on a number line. First, let us draw a number line here. 0 is a point which represents 0 is the point on the number line, and to the right we have to represent the positive rational number. To the left we have to represent the negative rational number. Now, for that, what we have to do, first of all, we know that 3 by 5 is definitely less than 1. That means it lies between 0 and 1. So we have 5 in the denominator. That means we have to make 5 divisions between 0 and 1. We have got 0 by 5 is 0, 1 by 5, 2 by 5, 3 by 5, 4 by 5, and 5 by 5 is 1. And therefore 3 by 5 is there. That means the point P on the number line indicates 3 by 5, which is the rational number on the number line, positive rational number on the number line. And so also minus 3 by 5, again minus 3 by 5 we can represent by taking 5 as the denominator. 0 by 5 is again 0, minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, minus 1. We have divided into 5 divisions here. So minus 3 by 5 represents point Q on the number line, which is minus 3 by 5, and that is how we represent 3 by 5 and minus 3 by 5 on the number line. We can also compare the rational numbers. The comparing means equal to, greater than, or smaller than. So first of all, write rational numbers with positive denominators. Remember how to find out which rational number is greater or smaller. Then for that, write rational numbers with positive denominators. If denominators are unequal, make them equal by taking the LCM of the denominators. Compare their numerators. Compare the numerators. The rational number with greater numerator is always greater. Now let us understand this by a simple example. Let us say we have been given two rational numbers, minus 4 by 9 and 5 by minus 12. Now we have to compare. Compare means find out which is smaller and which is greater. Now first of all, minus 4 by 9, minus 4 by 9 is there. 5 by minus 12, first write it in standard form because there is negative sign in the denominator. Make the denominator positive by multiplying minus 1 and minus 1 to P and Q. So we have got minus 5 by 12. But here the denominator is 9 for minus 4 by 9, 12 that is a positive 12 for 5 by, that is here it is 12 here. So find out the LCM of 9 and 12, it is 36. So make the denominator 36. To make 36, multiply 4 by 4 and 9 by 4, we get minus 16 by 36, and also 12 into 3 is 36, minus 5 into 3 is 15. So we have two rational numbers with the same denominator, and once we get the rational numbers with same denominator, compare the numerators. Compare minus 16 and minus 15. Minus 16 is definitely less than minus 15, and therefore minus 16 by 36 is less than minus 15 by 36. It means that minus 4 by 9 is less than what? 5 by minus 12, and that is the procedure. The procedure is again very simple. First of all, check the denominators whether they are same. If they are not same, make the denominator same by taking their LCM, and then find the equivalent rational numbers. Compare the numerators. Once you compare the numerators, whichever the numerator is greater, that rational number will be the greater rational number. Now to find rational numbers between two rational numbers. Infinite rational numbers exist between two rational numbers. We can find the required number of rational numbers between two rational numbers by different methods. So let us learn them.